curious that what this Vedic Neuron Processing Unit is. So I thought of making a special video on it.
So, let us start with the introduction. This is me, Anushka Tripathi, a third year student studying at Sri Ramdev Baba College of Engineering and Management. My skills are in digital circuit design, Verilog, C, and assembly language, and my experience includes I was previously a Connect Next intern at Dassault Systems, so there we worked upon 3D printers. Uh, we learned about medical grade 3D printers and we published a patent on a 3D laser based dimension measurement system used for a 3D printer. And I was a defense acceleration intern at IDEX DIO, where we worked upon TINA TI, Filter Pro, and filter design. So my project portfolio is in my very first year, I worked upon a project for Google Solution Challenge 2022. So there we worked upon a system where just by scanning the QR code on a oxygen cylinder, we could map the oxygen in the cylinder. So and after that, I made a project for IIT Roorkee Cognizance 2022, where we made an automated gardening system. And during the project for Dassault Systems, we did a consultancy project for Metlock Private Limited also, where we worked with CMM M443, and this is just the beginning. I'm working upon many more projects, many more ideas in the pipeline.
So I'm the author of one of the very famous newsletter on LinkedIn, Marvels of Party Maths. So this newsletter is an endeavor to uncover and promote the forgotten treasures of party mathematics with a flavor of programming. Through in-depth research, programming, and educational outreach, this initiative seeks to revive interest in party mathematics, and it also aims to make programming interesting for learners. Ultimately, the project aims to ensure that this rich legacy remains a source of pride and inspiration for future generations. So, when I was exploring the content for my newsletter, that is where the idea to work on this project sparked. What this neuron processing unit is. So they are optimized for neural networks and they can perform much better than CPUs and GPUs. So a neuron processing unit is a microprocessor that specializes in the acceleration of machine learning algorithms, typically by operating on predictive models such as artificial neural networks or random forests. So it is also known as a neural processor. So we already had CPUs. So why do we really need a neuron processing unit? So CPUs are very much great at processing highly serialized instruction streams, but machine learning workloads tend to be highly parallelizable, much like a graphics processing unit. So that is why we need a neural processing unit. So why do we need a neural processing unit? So they have application in self-driving cars, monitoring a system or area from traits like security system involving real-time face recognition. And they are also used in improving the healthcare by accurate analysis and treatment and many other applications. So all these have exponentially increased the number of computations involved, and the previous approaches of using GPUs could not scale well. So this paved the way to design a processor which will perform better than these GPUs and cope up with the progress we are making in the field of machine learning. So NPUs are required for purposes like so they are used to accelerate the computation of machine learning tasks by several folds as compared to the GPUs. And they consume very less power and improve resource utilization for machine learning tasks as compared to the GPUs and the CPUs. So, what are the present day AI hardware challenges? So, with the increasingly sophisticated AI models, so they demand more computational power and energy consumption. So, the traditional hardware struggles with the energy demands of AI computations. So, let us see how we can get Vedic maths into the picture to solve these problems. So, how can we get the benefit of integrating ancient wisdom with the modern day AI hardware? So, Vedic mathematics emphasizes mental calculations. It can help us in reducing the reliance on computational resources and Vedic mathematics. It's our heritage, it's our pride. And integrating Vedic mathematic principles ensures the preservation of ancient mathematical knowledge, and it can also help us in minimizing energy consumption. So, I am doing this project as a part of my college research internship. So, the objective of this research internship is to evaluate the performance of Vedic neurons derived from Vedic mathematics sutras and compare their efficiency with the traditional neuron structure. So, we learned the detailed working of a neuron structure. So we explored how to do the digital circuit design of a neuron, and we are presently working upon that only. We are implementing the weight memory. So doing a project, if we do not learn anything from it, is useless. Doing project like this is equivalent to not doing a project. So during the course of this project, I will make sure that I make my digital circuit design skills very strong. And during this project, I completed a course on Verilog HTL fundamentals for digital design and verification by Udemy. And I watched the lectures on digital electronics by Mizo Academy, and presently I'm on a 100 days RTL challenge and practicing my HTL skills on HTL bits. Modern day digital world can never be imagined without multipliers. They play a very important role in digital signal processing applications like FFT convolution. So this world can't never be imagined without multipliers. So a multiplier plays a very important role in a neuron. So we are working upon the multipliers, and so we explored various different kinds of multipliers, and the Urdhava Sutra was one of them. And I made a very special edition to explain the implementation of this multiplier in my newsletter, Marvels of Bharatiya Maths. If you want to learn more about this multiplier, do check out this edition. And we did the structural modeling of the 8-bit multiplier of Urdhava Sutram and array multiplier, and Urdhava Sutra performed very well. So why did that really happen? And as a part of this project, we are exploring hybrid approaches that combine the traditional multiplication algorithm with Vedic mathematics principles. So this can involve using Vedic mathematics inspired for specific part of the computation while relying on traditional methods for others.
So, our future project plan is that we will be implementing the higher level architecture of this Vedic NPU, and we will use it as a real world application in a smart cycle. And we hope to demonstrate the improved performance of this NPU when compared to the traditional AI hardware. So it was a very limited introduction about the project. It could have been much more detailed. But next month I am presenting my project at IIT Mandi. There I will be giving even more detailed explanation. I hope to share that session with you all as well. Thank you.